This tutorial will demonstrate how to set up an internet chat server on the Raspberry Pi 2. In addition, a bot will be configured to interact with chat room users. The bot will respond to commands, send out notifications, and interface with hardware connected to the Pi's GPIO pins. On a breadboard, I have a solenoid and a motion detector connected to the Pi. The chat room is open on my phone. The solenoid retracts when a user types turn on, and the bot confirms the solenoid status. Turn off disengages the solenoid. When I put my hand in front of the motion detector, the bot notifies the room that motion has been detected. Rocket.Chat is used for the chat server. It's a full-featured open-source web chat platform. A Raspberry Pi 2 with a clean install of Rasby and Jessie is the host. An older Pi is not recommended. It's possible, but it wouldn't be compatible with these instructions and would require manual building. Before starting, please make sure your Pi is up to date using sudo apt-get update and sudo apt-get upgrade. My tutorials are quick-paced, but all the notes, links, and code are available on my website, rototron.info, and there'll be a link placed in the description of this video. Rocket.Chat is built with Meteor, which is a great open-source JavaScript framework that makes it very easy to write powerful web applications. Use Git to download the Meteor Universal Fork, which is built for the ARM processor used by the Pi. Then run Meteor with the version switch -v to download the pre-built dev bundle and finish the installation. Okay, that didn't work. Turns out there's a bug in the latest version of Debian related to SSL certificates. Hopefully it'll be fixed by the time you watch this video. If not, you'll need to downgrade to the previous CA certificates package. I'll cd to a temp folder and use curl to download the earlier CA certificates package. dpkg is used with the -p switch to purge the buggy version. Then dpkg again to install the downloaded earlier version. Again, this is only necessary if you get an SSL certificate error. Alright, now it's working. Meteor runs on a server-side JavaScript runtime called Node.js, which is also being installed now. Since this will take about 10 minutes to finish, as usual, I'll speed up the video. Now let's take care of Rocket.Chat. Create a Rocket.Chat directory and cd into it. Download Rocket.Chat with curl. Use tar to uncompress the archive file. A MongoDB database is required to store our chat data. MongoDB could be installed on the Pi, but because of the high write volume, it's probably not too good for your SD card, and there's a high risk of data corruption. mlab.com, previously known as MongoLab, provides a cloud-based database service. Their free sandbox package provides a single database with 500 megabytes, and no credit card is required. I already signed up, so I'll click Login to log in, click Create New to create a new database. mlab gives you the option of Amazon, Google, or Windows Azure to host your database. They handle everything, so you don't have to worry about configurations or paying for anything. I'll stick with Amazon East Coast and click Single Node, which is the only free option. Enter Rocket.Chat for the database name, make sure the price is 0, and then click Create New MongoDB Deployment. Okay, success! The Rocket.Chat database is ready to go. Click on the new database name to open it. A database user account is required to connect to the database, so click here to create one. I'll use rdagger for the username and confirm the password. Click Create to add the new database user. Make sure read only is false so that the user has write permissions. Scroll back up and highlight the MongoDB URI, which we'll need later, so copy it to the clipboard. Back in the terminal, cd to the Rocket.Chat Bundle Programs Server folder. npm install, which is located in Meteor Dev Bundle Bin, is used to install the dependencies required by Rocket.Chat. They are specified in the current folder's package.json file. npm is the default package manager for Node.js. Rocket.Chat is now ready to go. For a quick recap, we've installed Rocket.Chat, a web chat platform, Meteor, an ultra-simple web development environment, and Node.js, a JavaScript server-side runtime. We've also set up an online MongoDB database and used the Node package manager. cd ... is used twice to back up to the Rocket.Chat bundle folder. Rocket.Chat will be started from this folder. There are a few environment variables, so I'll create an optional startup script called blastoff with touch. chmod +x to give it execute permissions. Use nano to edit the blank startup script. Set port equal to 3000. The root URL can change, so a variable 1 is substituted. This root URL value must be passed as an argument to the script. Change the Mongo URL to the mlab URI that you copied to the clipboard earlier. Be sure to replace the placeholders for username and password with your actual database username and password. The last line runs Rocket.Chat. Save and exit the file. The blastoff script is now ready. Type /blastoff followed by the root URL, which for now will be localhost. After a couple minutes, the server should start. It's not very obvious, but this last line with date and time indicates Rocket.Chat is up and running. Open a web browser and go to http://localhost:3000. The Rocket.Chat logon screen appears. Click Register a new account. This will become the administrative account. Enter your username, email, and password. Then use this username. Okay, we're logged into the chat server. Currently there's only one room called General and no messages. You can see I've joined it and I could start chatting down here by the cloud icon. The arrow next to the username gives you access to the administration. You can modify permissions, rooms, users, and much more. I'll log out and close the browser. Other computers on your local network can access the Rocket.Chat server. You just use the IP address of the Pi instead of localhost. Type hostname-i to get your Pi's IP. In my case, it's 192.168.192.12. Open a new browser and type in the IP followed by :3000. A warning pops up that the site URL has changed. Click Yes to change the site URL from localhost to the new IP. You can confirm the site URL under Administration, Settings, General. I found that the mobile phone apps don't work unless the site URL is correct. I'll log out and exit again. Currently, the chat server is only working on my home network. To make it work anywhere on the internet, there's a free service called Ngrok. I'll browse to Ngrok.com. I already have an account, so I'll log in. This service is more secure than using dynamic DNS and exposing ports on your router. For Raspberry Pi compatibility, download the Linux ARM version of Ngrok. On the Ngrok dashboard auth page, copy the provided tunnel auth token to the clipboard. You'll need it later to enable HTTPS access for your chat server. Open a new terminal, create a new folder called Ngrok, and CD into it. The Ngrok zip file was downloaded to my Downloads folder. Unzip the Ngrok file to the current folder. Inside there's a single Ngrok file. The Ngrok file is run with the auth token switch to set the authentication. Paste in the token we just copied to the clipboard from the Ngrok website. You only need to do this procedure once. Now you can start Ngrok with the HTTP switch set to port 3000. The Ngrok status screen will provide you with the HTTPS URL that you can now use to access your Pi from the public internet. Copy this URL to the clipboard. This URL can now be used from anywhere on the internet to access the chat server. Back in the browser, there's a warning that the site URL has changed from the local IP to the Ngrok address. Click Yes to fix it. Even though everything is working, it's a good idea to restart the Rocket.Chat server anytime the site URL changes, or else you may encounter problems. Use Ctrl+C to stop the server. Blast off again, but this time change the site URL to the Ngrok address, which we can paste in. Okay, after a couple minutes, the chat server is back up. Now let's give users in the chat rooms the ability to interact with the Raspberry Pi using a bot. I'll log out and click Register a new account. The username should be bot. The email doesn't need to be real, and give a good password. Click Use this username. I like to give the bot an easily recognizable avatar, so I'll click My Account and click Change Avatar. Click Select File and pick a picture. Then click Use Uploaded Avatar. Now log out the new bot user. Hubot is a bot that monitors the chat rooms and responds to commands or keywords. You can write custom scripts to perform actions such as turning on devices like an LED, motor, or a solenoid. You can read inputs such as a switch or a sensor, and you can also have Hubot post messages to chat rooms in response to events such as motion detection or temperature warning. In a new terminal, add the Meteor dev bundle bin folder to the path. We can now npm install without preceding it with the long folder name. It's important to use npm update with the global switch to ensure that the Node.js package manager is up to date. Otherwise, Hubot might not work. The Hubot generator is installed with npm install. env path equals path ensures that the new path stays in scope with sudo. This takes around 15 minutes and you may receive a few warnings or errors, but it still works. In the home directory, make a Hubot folder and cd into it. Type Hubot. You'll be prompted to answer several questions. Use your username or email for the owner. Bot name should be bot. You can put anything for the description. The bot adapter should be Rocket.Chat. Hubot is now installed. There are 5 environment variables, so I'll use a script to start Hubot. Use touch to create a blank startup script in the Hubot folder called Robot.Activate. chmod +X to add execute permission, then nano to open it for editing. Rocket.Chat room is left blank, so it'll default to the general room. Listen on all public is true to listen to all public rooms. Rocket.Chat user is bot. Rocket.Chat password is the password assigned when you registered the bot account. Rocket.Chat auth is the type of authentication, which will be the type password. Meteor Dev bundle bin is added to the path. Finally, Hubot will be started with the Rocket.Chat adapter. Save and exit nano. In order for Hubot to access the Pi's GPIO, I'll use npm to install a Node.js package called OnOff. It provides GPIO access and interrupt detection. There are a substantial number of Raspberry Pi related packages for Node.js, which you can check out at npmjs.com. The Hubot folder contains a scripts folder. Scripts are programs that control how Hubot interacts with the chat rooms and the Pi. Our custom code will go into the scripts folder. Currently, scripts contains a sample called example.coffee. I'll open it with nano. The file contains a link to the full documentation. The scripts are written in CoffeeScript, which to me looks similar to Python but actually transpiles to JavaScript. There are many commented out examples in this file that you can experiment with. The program starts with module exports robot. There are functions like robot here, which listens for specific words or phrases in the chat rooms and can then send a response. For example, it can send a response anytime a person uses the word badger. The robot respond function is like here, but it only works if the robot's name or alias is immediately preceding the keyword. The chat user would address the bot, which could then reply. To save time, I'll paste in some code. I'll instantiate a GPIO from the OnOff library, set up an LED on GPIO 21 configured for output, set up a push button on GPIO 20 configured for input, and set edge to both to get rising and falling inputs. Button watch creates an interrupt for the push button, which will fire when the switch state changes. The function receives two variables, error and value. Error is for error and will be logged if any. Value is the state of the push button. True equals the button pressed, and false is released. Anytime the button changes, the bot will send a state message to the general chat room. Robot here will listen for the phrase LED on, then use write sync to turn on the LED and notify the room. 1 indicates on. Another robot here listens for LED off and will turn off the LED. 0 is off. A third here will listen for the words GPIO pinout. In response, the bot will send an image of the Raspberry Pi GPIO pinout. Exit will be called when the bot stops and makes sure the GPIOs for the LED and button are cleaned up. Save the code and exit nano. Here's a simplified schematic for the demo code. A 330 ohm resistor limits current to an LED on GPIO 21, a push button is connected to GPIO 20, a 1000 ohm resistor limits the button current, a 10,000 ohm resistor functions as a pull down so the button input doesn't float, and a 100 nanofarad capacitor debounces the button. On a small breadboard, I add a yellow LED. The LED cathode is connected to ground using a 330 ohm resistor to limit the current. The LED anode is connected to GPIO 21 on the Pi. A momentary push button switch is added to the breadboard. One switch terminal is connected to GPIO 20. A 10K ohm resistor ensures that the input is pulled down when the button is not pressed. A 1000 ohm resistor connects the other switch terminal to 3.3 volts. Now when the button is pressed, GPIO 21 will change from low to high. A 100 nanofarad capacitor is placed across the terminals to debounce the switch. This prevents a single button press from registering as multiple presses. Finally, a 3.3 volt pin from the Pi is connected to the breadboard's 3.3 volt rail, and the grounds are also connected. Okay, that takes care of the hardware. In terminal, type /robot.activate to start Hubot. Everything is good to go. I'll log back into Rocket.Chat and join the general chat room. You can see that the bot is now listening in the room. In the general room, I type LED on and the LED illuminates. The bot also announces the event. I can turn off the LED with LED off. The bot announces that I'm pressing the push button, and also when I release it. If I type GPIO pinout, the bot sends me the pinout graphics, which I can enlarge. I'd like to give a shout out to the Rock on Pi chat room. Thanks to the friendly members and quick helpful responses to all my questions regarding Rocket.Chat on the Pi. The Rocket.Chat Raspberry Pi GitHub site also has a ton of information and a FAQ. I hope you found this video helpful. You can support this channel by subscribing or leaving a like. Thanks for watching.